Hello students. So today this is the first class of the topic called motion, and this topic is basically in your all of you, as you can see in your class 9th and class 10th syllabus, and we will be also covering a little bit aspect of your NTSC exams. If you don't know much about this exams, you will be getting the information very soon on our channel, so do subscribe to our channel and visit our website examrat.com and just leave a comment how did you like this lesson. So thank you for joining, and let's start with this lesson. So now coming to the topic, that's motion. So all of you would be having doubt that what is motion. This is the I would say this is the first chapter of your physics of class 9 syllabus. Okay, in class 10th, if you are in ICSE board, you might have this syllabus as well. So in ICSE you may get in class 10th as well. So let's start with the question. Let's start with the topic. So now if we start with this topic, the first doubt would what would be coming in your mind is like, what is motion here? Like, I have heard of so many things. I have heard of motion. It's there in my topic. Now what is motion? And this is something, all of you would be very interested about, that what is motion. So now let's just take a simple example over here. So as you can see, there are a lot of balls. For you guys, I won't name it as pendulum. Just you can just imagine these are the balls tied with threads, okay, on the top of this kind of arrangement. Now there are many balls, and if I just take one ball from here and I just try to just hit this ball, so it's quite obvious. Even you can just see from here that if I'll just try to hit the second ball, this is the second ball, this would also hit the subsequent third ball, and then after fourth and then fifth. So this is, all balls will start moving. So in the bookish language, if we talk about what is motion, so this is a definition what you will find in your books, that this is motion is a phenomenon in which object changes its position over time. Now you will be thinking, yeah, what is an object? So object, I've already told what is an object over here. This is a ball. Now it changes its position over time. So I'll just give a very small example. Let's suppose you just start riding your cycle. So right now you are in your home, just out of your home. Like, let's suppose this is your home. I'll just name this at H, and this is your school. So now the moment you just start riding your bicycle towards the school, the motion will start. As per the book, as per the knowledge, as per the definition, your motion will start from your home and it will end at your school when the moment you reach school. So at that point of time, whenever you're riding your cycle from your home to your school, you're performing a phenomenon that's called as motion. And if in exams they ask you what is motion, so you can just write down this definition, that it's a phenomenon in which an object changes its position over time. And one thing more, guys, whosoever is seeing this video, it's my humble request to you all students that just take a copy, just take a notebook with you, and just start writing down whatever the definitions you're seeing. Just pause the video and you can just write down the definitions. It would be definitely helping you, and the PDF notes of this lecture would be there in the description. You can just check down the link below. Do follow us on Instagram as well, and yeah, if you have an account, that's all. I'm not asking you to just join the Instagram. Anyways, so coming to the motion aspect, so you just start motion from your home and your motion ends at, let's suppose you reach your school. So till this time, so definitely there would be some time involved in it. Like, let's say your home is 5 minutes far. You just say my home is, I just take 5 minutes to reach to my school. So this time involved in this motion, so that's why it's called, and definitely your position in starting, initial position would be at home, and now you are standing at your school gate. So there's a change in position, as you can see, from home to your school, whatever the distance you would have been covering. So there's a change in position, and that's what the definition says, that a phenomenon in which an object changes its position over time. Now there are many methods on which many metrics on which how we can judge whether motion is happening, what's the type of motions and other things. So as of now, what is motion? So there's nothing to learn about it. Just you can just see this diagram, and there's a small example of this, and what is motion. Okay, now it's clear ki what is motion. Now let's come to the second topic, that what is motion in straight line. So there are 2 to 3 types of motion we would be seeing in your NCERT books. You can see in your school textbooks that there are 3 to 4 types of motion. So first basic form of motion is your motion in straight line, as you can see over here. That's also called as 1D. I'll just come to that, what do you mean by 1D and what is the motion in straight line. So you can just see 2 figures over here, okay guys. So this is the first figure in which there's a this is a track of a railway track, right? This is a railway track in which a train is going towards front. Now let's suppose that there's a straight railway track like this. I'm sure so many of you would have been into train in your life at least once also. So you would have observed that when you sit inside the train, there's a reference that when you're sitting inside the train either moves, like for you always it will move in the front direction, but it also can move in the backward direction, and that's quite obvious also, that if you are moving on a road, this is a, let's suppose this is a road you're moving, so your car can either move in front direction or your car can move in back direction, like reverse, that's what we call. So there's no possibility that your car can go up and your car can go down, right? If you guys are getting my point, then this is very clear that the motion is happening in straight line. I've already told what is motion. Now if the motion is happening in straight line, so definitely that's called as motion in straight line, and that's also called as 1D. Now D over here stands for dimension, so you can just write in your notebook that D over here stands for dimension, and 1D motion means motion in one dimension. One dimension means that motion is either happening in towards front, or motion is happening towards back. Or there's another aspect of this as well, that motion can happen in top or motion can happen in down. Like let's suppose this rocket, okay. Now the moment you just start fueling the ejecting the fuel, this rocket starts to just take off. At that moment this rocket is going up. So this is definitely a motion in straight line. And if this rocket comes down due to gravity, because our earth always attracts everything. Whenever you throw something up, it always comes down, right? So that there's a gravity involved. Anything you just throw up, it will come down. You will be learning about this concept very soon in your other videos, other topics. So if this rocket comes down, and let's suppose it just went halfway in the sky, and at that point of time it just exploded, and the reason for which it was made, it was unsuccessful. At that moment, that explosion, whatever will happen, this rocket will try to come down, and this would automatically happen because gravity is actually pulling it. So gravity is pulling the rocket towards it. Now either this rocket, so that's why I am saying that either this rocket can go up by ejecting the fuel downwards, or this rocket can come down. So this is also motion in one dimension. Example, okay. Now if you just say that you just threw a ball into some direction, let's suppose you just threw not if you're throwing the ball vertically on your top like this, then definitely it's motion in one straight line. But if you throw a ball at some angle, at you just try to throw a ball like let's suppose you are playing tennis, and you just try to throw the racket from your try to throw that tennis cock from your racket. At that point of time, it's not motion in straight line, because if the tennis cock would be going something like this. So in the next video we will be discussing about this type of motion. This is called as projectile, but as of now let's not go deep into that. Motion in a straight line, you would have I think it would have been clear by now. Now there's a trivia for you guys, and this is the kind of homework what I want to give you guys, that now just try to find out what is linear motion. In the next class, that's your second class of motion, you will be getting the answers for this, that what is linear motion. This is somewhat similar to straight line motion. I just want you guys to just go on Google and try to ask your seniors or teachers or something, that what is linear motion. That's actually an interesting topic. We'll just come to that in the next class, like just for a minute or something. Anyways, now coming to the next topic, that okay, now I'm done with straight line motion. Now there's a topic in my syllabus called as uniform motion. Will you teach me? Definitely. Now what is uniform motion? This is a okay, so just for an instance, let me tell you guys that in this lesson we are not particularly dealing with the numericals. I know that these are very important aspects when it comes to your competitive exams, your Olympiads, your NTSE, and even in your school exams also they would be asking numericals. But numericals plus your school questions, specifically NCERT if I talk about, and some of the MCQs. These all three types of questions we would be discussing in the next class, or maybe in the third class of motion, where will be the topic getting ended. At that point of time, we'll discuss the numericals, NCERT questions, and MCQs. But as of now, we'll just try to understand the theory aspect of this chapter in this topic in this video. And once the theory aspects get clear, guys, trust me, solving numericals is not at all tough, and especially in this chapter. And I'm here, our team is here, we will be helping you out, you guys. And yeah, so now coming to the topic uniform motion, as you can see. Now just let's take very simple example, okay. Let's not just come to the book questions and book definitions. Let's just take a very simple example, that you just went on in your cycle, you just went to market. Let's suppose you just went to market. You are going to market. Like this guy is going to market near to his home. Now the moment he just takes his bicycle from his home, okay, You just take out from the garage, and you just get yourself padded up, and get yourself on the road, that okay, now I'll just start to pedal my cycle and I'll just go to the market. Now the moment this fellow just comes out on the road, he is not in motion. So at that point of time, definitely he's on rest, he's standing, like your cycle is in your hand, but you're not riding it, right? So at this point of time, motion is not happening, guys. But the moment he starts pedaling his cycle, the moment he just starts to pedal, that moment motion will start to happen. And definitely, as you can see, he's moving in this direction, he's riding the cycle in this direction. So it's a motion in straight line, right? He's doing a motion in straight line, that too in this direction. So now just coming to the topic, uniform motion. Now what is uniform motion? So this is a standard definition what I've got for you guys. As you can read over here, read with me. If an object is traveling with uniform motion, it is moving in a straight line at a constant speed. Now what is a constant speed meaning for you guys? Because we will be coming into the topic called as speed in the next coming slides, but as of now, over here in uniform motion definition, the word has come speed. Now speed, all of you would be knowing, when you drive a car, when you ride a bicycle, when you ride a scooter, anywhere you just go, if you go in train, if you go in flight, everywhere there's a term you would be hearing that is called as speed. And you guys are in class 9th and 10th level, definitely you would be knowing what is speed, right? There might be a problem with definition, but you know that speed is something that's making me to go from one place to other place. And if that's very clear that if my speed is more, if I'm riding at a high speed, that definitely I won't suggest you to do. But if you're riding at high speed, definitely you will be taking less time to reach to some point, right? Now constant speed means, like I'll just give you a very simple example, that let's say this is your car, and you with your family you just went out, and let's suppose, for example, your driver is driving a car. Then on the road you would be getting so many hurdles, like, right? So there would be traffic jams happening, there would be red signals on the road where you have to stop your car. So the speed is constantly changing, if you can just observe, because when you started from your home, your speed was 0. Definitely you are just at rest, you're standing, you're sitting in the car, speed is 0, right? You started giving some speed to your car. Let's suppose you just started giving some speed, and you just started going on the road. Now speed is definitely not fixed if you're traveling on a road, and it's not even fixed in real world. But just for the solving questions, we would just, let's suppose that you are traveling at a constant speed. Constant speed means that you're not changing your speed. Let's suppose you just you're traveling at a speed of, let's say, 10 meter per second, and this speed you're not changing. That means that there's no hurdle, there's no breakers, there's no traffic signals, there's no anyone in the road, and you're just moving at a constant speed. So at that point of time, your motion would be called as uniform. Uniform is a word which basically means that no change. So I want you guys to just write this meaning. Uniform equals to no change. So uniform motion is that, like, this guy, he just came on the road. The moment he started to pedal his bicycle, and just a second before he reached to that shop, to that market, till that point of time he was doing uniform motion. That means that his speed was constant, he was cycling at the same speed throughout, and at that point of time he was doing uniform motion. So I hope so this topic of uniform motion concept would have been clear for you guys. Like, there's an example you can just read over here. When a car travels at constant speed, the driving force from the engine is balanced by resistive forces such as air resistance, frictional forces, and car moving parts. Again, these all are a little bit fancy words for you guys at the starting of class 9th level. Definitely we would raise your level to up to NTSC marks. But as of now, just this is the starting of the topic. So let's just not get deep into this example, but I can just tell you in simple words what this means. That your car is traveling at a constant speed. What I just now I told you, constant speed means that you are maintained a fixed speed, okay? And the driving force from the engine. So what is driving force from the engine? I'm sure you guys would be knowing that if you're riding a car, there is a pedal called accelerator. That's in the right side corner, and that pedal accelerator actually just helps your car to accelerate. We'll just come to these all terms. Don't get confused, guys. Again, what is accelerator, what is acceleration? Don't get confused. We will be coming to these all terms very soon in this topic only. Just I'm giving an example. If you don't understand, it's quite okay. You'll be understanding in the upcoming videos. Engine is balanced. Resistive forces such as air resistance. Definitely if you're moving, air would be trying to just stop you, just trying to stop this guys, but still this guy is moving, and he's opposing the air resistance and the frictional forces in his car moving parts. So this is an example of uniform motion. And now let's just come to the second topic. And now this is a very interesting part. Like just before coming to the second topic, let me just ask you guys that just a second. Yeah. Okay. So let me just ask you guys that if you are just doing uniform motion, then you are traveling at a constant speed. Okay, so now you are telling that I'm doing uniform motion, then only I'm at constant speed. So what if my speed is not constant, right? Because if you're traveling on a road, definitely your speed would be changing. Your speed your speed would be changing if you're traveling on a road. You cannot maintain constant speed, guys. That's very obvious. You would be going to your school, you would be going to your colleges, you would be seeing that on the road there are so many hurdles, right? As I told. Now if you are not in a uniform motion, that's called non-uniform motion, where speed is not constant, you're not moving in a straight line. Okay, non-uniform motion. Then how can you measure the rate of motion? So what is rate of motion? I'll tell you. Measuring rate of motion. So now I'll just give you an example. Just for the matrix means the parameters. I'll just give you a very simple example, guys. That we all know that marks doesn't matter, and it's much beyond marks your life is. But now if a student is in class 9th, okay, for example, you guys are in class 9, and someone comes to your home, and the person whosoever comes, maybe your relative, maybe your friend, anyone, they just ask you that what is your marks in your previous class. Let's suppose you got 80%, okay. Let's suppose you got 80%, and then they'll ask the what was your friend's marks. You just say 90%. So at that point of time, marks are the metrics. For example, at this point of time, marks are the metrics. What is measuring? What marks are measuring? The rate of, not rate of, I would say marks are the metrics which are measuring who's more genius, who's more brilliant. Definitely that's not in reality, but at that point of time, that particular relative or that particular friend of yours doesn't has any other metrics, right? If he wants to ask you that who is more talented in you both, there unfortunately that's only the metric left with him or her. So he would be asking what is your marks, and if your marks are more, definitely he would say, "Arey yaar, you are more talented than that person. You are more genius than that person." So this is an example. What does metrics means? Now let's come to this topic, that metrics for measuring the rate of motion. Now there are so many things through which we can just measure how the motion is happening, how the if you're going from place A to B, if you're going from place A to B, you can go like this. I can go a path like this. I can travel in a straight path like this. I can go like this, and just roam whole over the city and then just come to B. So there are so many paths. There are so many ways. I can just go in a very high speed to B. I can just slowly go to B. So and in all of these things, time would be involved. So I can take more time in going to from A to B. I can take less time in going from A to B. So there are so many ways on which I can just go from A to B, and this are called as metrics. So metrics are just the parameters. These all are the terms. These all are the scientific terms on which you can just check the rate of motion. Rate of motion is like how fast motion is happening, how quick motion is happening, how much less time it's taking, how much less distance it's taking, displacement, and so many things are there. So don't get worried by seeing these all fancy terms. We will be seeing what these all means, their definitions, their units, their formulas. We will be solving questions on that. So just for an instance, I have written down over here. So we will be seeing the speed. Like what is speed? This is a metric on on which we can judge motion, how fast motion is happening, right? So you can just go in a very high speed, you can travel in a very low speed. So speed is one of the key metric in which we can judge motion is happening and its rate of motion, right? Second metric is your distance. Third metric, as you can see, is your time. You can take less time, you can take more time. Displacement, this term you guys won't be knowing as of now at starting of your class 9, but just in this video itself, I'll just try to explain you what this term means. Till here we are covering in today's video, and in the second video we will be covering these all topics. So after this, your motion chapter would be completed from your class 9th and your class 10th ICSE syllabus as well. So these are four metrics we are going to discuss now. A fifth metric is velocity, acceleration, average speed, average velocity, and there can be so many, but at your level at this point of time, only these 8 or 9 are important for you. Now let's just jump into the topic, that what is speed. Now you are saying about speed. Now let's just jump into the topic. I'm sorry. Before speed, I would just like to just tell you guys about give a brief idea of distance. After that, we'll come to speed, because there's a use of distance in that speed. So now come to the speed. So what is speed? So as you can, sorry, now let's just come to distance. So I'm sure you guys would be going on a road, and you guys would have seen these all boards, signboards. You would have seen that your Haldwani is 18 kilometers, and there's an arrow marked over there. If you can just see, there's an arrow marked over here that your Haldwani 18, it's written Nainital 58, and then written Almora 11. So these are just the random names of a place called Uttarakhand, and I just got this photo for you guys. So now you can just see there are three signboards. This signboard is just depicting an arrow over here, and just written the name of the city or name of the place, and in bracket they have written the some date, some number they have written 18, not in bracket actually, they have just written some number. So Nainital 18. So okay, now let's suppose if your name is Ayush, and Ayush is going on this road, and he just sees this banner, he just sees this board, okay, and now what this board is telling that Nainital is 58. Now what does this 58 means, and what is Nainital? Nainital is definitely a place where Ayush wants to go. This arrow shows that okay, Ayush, you have to go straight on this road, just go straight. Okay, now what is 58? Now this 58 is nothing guys but your distance. Okay, now we'll just try to see, because see, these all things, it's okay if you are understanding, it's very good, but in your exam definitely you have to write, what is distance, you have to do the numericals on these all topics. So that's why whatever it's written over here, or I'm telling you guys, just pause the video, because in video it's not specifically possible for me to just stop for you guys and wait for you to write. But you guys, I just want you to pause the video and prepare proper notes. Anyways, you would be getting the PDF of this slide on the in the description box, but still I would just suggest, if you write yourself, you just get a better clear view. Okay, now this 58 is nothing but the distance. Okay, now distance is something like, let's say this is your school, this is your home, for example, H, and this is your school at this spot. Okay, now you are going daily from H to S, daily you are going to H to S, and then coming back to from S to H. Now if I just ask you how far is your school from your home, so there is a metric called as distance. So you can say that my home is 2 kilometers far from my school, or my school is, let's say, 5 kilometers far from my home. So this is called as distance, and as you can just read the definition over here, bookish definition, and I just want you guys to just read with me that distance is a rate of change of position, its position with time. So this is all. So this is one definition, and if you write this much also, it's more than enough. This is also, I'll just tell you, or the magnitude of the change of its position per unit time. Now for what person, or for what it's written over here, its position. So what it means over here, it means that the object for which we are talking about, like let's suppose you are going in your car. Now if I just ask you what is the distance your car is traveling, or how much distance are you going to travel, so this is a definition that distance is a rate of change of position with time. So let's say you're traveling 2 kilometers. Oh, it's the speed. Let's say you're just traveling 2 kilometers. Now you are taking time, let's say for 2 minutes. Okay, 2 minutes are taking. Now you are traveling 2 kilometers in 2 minutes, then there would be a speed involved in that. You're moving at some speed, and then it's called as then you can just cover something distance. So distance is nothing but now let's just come to the formula of distance. Okay, formula. What is distance? So this is a definition that it's the magnitude of change of position. So change of position means, let's say you were at this position and now you are at this position. So how much position you have changed, how much distance you have traveled, that is only the distance, right? So now let's say if you travel 2 kilometers, so this is the distance, right? So that's what the definition. Now let's just come to the formula of distance. Okay, this is also important, and I am telling you guys 4 points. So this 4 you should remember if in your exam it comes. I want you all to just write these all 4 points. Okay, so sometimes they might ask the difference in the difference part. Okay, so they may ask that okay, tell me the difference between distance and displacement, or something else, some other quantity. So if you know these 4 points, you can just you can just write over there. Now what is the formula of distance? So now, just as of now, I just want you guys to just remember this. We will be solving numericals. At that moment of time, you would be getting clarity of what this formula is about and why is it happening so. But as of now, I just want you guys to just remember this formula, that distance is equals to your speed into time. And this is a very basic and very simple formula. Everywhere in life, this would be coming to you, and this is not going to leave you away. Trust me, guys. And even if you go for different streams, this is a very common thing, right? Everyone travels in their life, everyone moves from one distance to another, and if you know these all formulas, your life actually becomes easy. No one will actually come to you and ask that, okay, now calculate the distance of my speed is this and time is this. But at least if you know the difference of distance and the displacement and these all terms, it would definitely help in life, and in exams, so definitely it's going to help. So distance is equals to speed into time. It's the rate of change of position of the body with time. Now coming to the third point, that what is its unit? Now you guys would be asking that unit, what is unit and why have you written unit over here? Okay. Now unit is something on which we just measure the things. Okay. Now let's suppose that your mom just went to a milk vendor and just asked him that, okay, now okay, bhaiya, just give me 2 liters of milk, 2 liters. So now 2 liter, what does it means? 2 means the magnitude, and what does liter means? Liter is a unit on which you can measure something, volume of something, right? Now she cannot go and tell to that milk wala that just give me 2 kilometers of milk, right? She cannot tell that give me 2 meters of milk, or let's say give me 2 kg of milk, because milk, we have, it's like a water, it's like a liquid, okay, and we measure it in volume, and for that the unit we use is liter. Now if you're going, let's say I just ask you how far is your home from your school, you won't say that it's 2 liter far, right? You have to say it's 2 kilometer if it's 2 kilometer. So that's what unit is, that on which basis we are just defining that particular specific quantity. So unit of distance is your SI unit is your meters. I'll just write the definition, I'll just write in full form, and we represent it as m. So just write it as m, or in the long picture we also use sometimes as kilometers. Okay, so distance unit is also kilometer, that's represented as km, as written over here. And now again there's a trivial question for you guys, and just comment down below that how many meters are there in 1 kilometer. Okay, now I know guys these are very easy questions what I'm asking you, but at the basic level, we are just seeing all of the students right now, because everyone learning curve is different, and so many things are there. But subsequently, trust me guys, we would be raising the level, and once you're thorough with the theory portions, we would be coming to the numerical as well. Okay, now your unit for the distance is meter or kilometer. That means that if I want to measure the distance, okay, let's say this is a pen. If you can just see, I'm not sure, this is a pen. If I just ask you what is the length of this pen, length means how long is this pen. So you will say, let's suppose it's 1 meter long, though it's not, but let's suppose you just say it's 1 meter long. Now you cannot say this pen is 1 kilometer long, right? So there's a specific unit for everything, but specifically if we talk about distance, we just measure it in meter or kilometer. Okay, let's not just go deep into that, what is unit and all, because that is a topic of detailed topic is of class 11th physics first chapter. If you just guys would take science in class 11th, you would be studying that. Anyways, now fourth point, I have written that it is a scalar quantity. Now you guys would definitely come and just just get a doubt that what is a scalar quantity. In our class, in our school, no one just taught us what is scalar quantity, and even I don't expect you guys to understand what is scalar and what is vector at this point of time. Just I'm telling about the distance, 4 points, guys. I'll just tell you in brief what is scalar quantity, but for the detailing, I'll just when we are discussing the differences between displacement and distance, at that point of time, I'll just in the second video we'll just let you know in little bit of detail that what is scalar and vector. As of now, scalar quantity means, so there are two types of things. Okay, I'll just tell you. Like you can see the arrow over here, if I'm not wrong, guys, that this is the arrow in this board, distance board, that this is an arrow. Okay, now let's say Nainital, and this arrow is there. What if this arrow was in this, like this, it was written Nainital over here, and this arrow was showing over there. So what does this mean? That you have to go this way, right? And if the arrow is in this direction, in the front direction, top direction, you have to go in front. So, and over here it's written 58. Okay, now I'll just rub it for you guys if it's getting a little confusing. You can just see over Nainital. Okay, 58, and there's one arrow. Okay, so what does this arrow mean? This arrow means that you have to go straight on the road, and this 58 means that it's 58 kilometers from here. Okay, now if I just tell you 58 kilometer, then that means I'm telling you my distance, that how far is Nainital from here. Now if I just tell you, if I just write this arrow also, then what does this arrow tells? This arrow tells that it's in front direction. So 58 is your 58 kilometers is your magnitude. Okay, just this over here also the word magnitude has been used. So just write in your notebook, draw this okay, draw this banner and just write 58, and just make an arrow over here and just write 58 is magnitude, and in this arrow you just write bring the arrow down and just write direction. So this arrow is depicting us the direction. So magnitude plus direction is called as vector, and only magnitude is called as scalar. I know it's getting a little bit confusing for you guys, so let's not just go very deep into this. While discussing the difference between distance and displacement, we'll just see what is the difference and why is it scalar quantity. As of now, just write this point that it's a scalar quantity, and just let's come to the second topic of our today's lecture, that's speed. Okay, now speed. I'm sure all of you would be knowing, and almost everyone among you would have once or ever sat in a car, or let's say in a bike, or let's say in a scooty. So you would have seen something tachometer or something like this. Okay. Now what does this meter says? So it's over here, as you can see. I can't just zoom for you guys, but if you guys can just see over here, it's written kilometer per hour. Okay, and this is reading. The markers are given over here: 0, 10, 20, 40, 60, 80, 100, and like that. Okay, and there is one needle. Okay, in starting, if you are sitting in home, you can just go and observe over there that this needle would be pointing at your 0. Then what does this needle pointing at 0 means? That right now the speed of your particular vehicle is 0 kilometer per hour. Kilometer per hour is again the unit of the speed, and we will just see in this slide itself. But this, what does this depicts, this tachometer? This just tells us the speed. Okay, what speed the particular vehicle is having. Now it's very clear for you guys that if speed is more, okay guys, if the speed is more, you are traveling in less time. So I'll just give you a very simple understanding trivial example for you guys. So you guys just started from home, and you guys just went till your school. Okay, home to school, home to school. I'm not writing because it's getting dirty, the whiteboard, but I'm just showing you over here that you guys are just going from home to school. Okay, here is your school, here is your home. Now let's suppose today you just went slowly. So if you go slowly, you will take more time, right? That's very common, guys, right? If you go slowly, you'll take more time, and if you go fast, if you just go very fast in a race car or something, it'll take less time. Now there's a phenomenon behind that, and that's called as speed. No, okay, you all of you would be now you're saying to me that, okay, I know what is speed, but how to express myself? Okay, how to just define speed, and what is the unit? How can I measure the speed? Okay, what's the formula to calculate speed, and how is speed different from distance, and blah blah blah. So many questions will be coming to your mind. Now let's just come into this, that what is speed. So this is a book, from your NCERT book only I've taken this definition. You can just see. Speed is your magnitude of rate of change of its position with time. Now what is your rate of change of position, and what is your time? Now let me just tell you guys that one second. So rate of change of its position. Now what is change of its position? Let's just break this definition into parts. Now what is the change of position? Change of position is like from your home. Initial position was your home, and now your position is your school. Now your position is school. So this change has happened in your position. Like in morning you were just in your home, and in afternoon you are in your school. So now there's a change in position. So okay, now halfway I'm done. So what is change of position? I know. With time and rate of change of position. Now what is rate of change of position with time? Okay, I'll just tell you. See, let's suppose you just at 8 a.m. you just left your home for your school. Okay, and in 10 minutes you just reached your school. At 8:10 a.m. you are in your school. Now at 8 a.m. you were at your home, and at 8:10 a.m. you are now in your school. So the time involved over here is 10 minutes, as you can just see. Okay guys, now, and the distance, let's say, from your home to your school is a kilometer. That's 1 kilometer, let's suppose. For example, there's a 1 kilometer distance, you're traveling in 10 minutes. Okay, now you guys would be thinking that, okay, now what is rate of change of position mind? So now your position change is 1 kilometer, and with time means in 10 minutes. So now you can just tell to someone that I have traveled 1 kilometer in 10 minutes. Okay, now I guess you guys would have understood this thought, that you are traveling 1 kilometer in 10 minutes. Now your rate of change of position is 1 kilometer, and change of position is 1 kilometer, and if we talk about rate with time, it's in 10 minutes. So now you have to just calculate the speed. So this is actually little bit confusing for you guys in starting of your class 9th. I understand. Just try to just see the definition. In the subsequent videos when we'll just solve the numericals, you'll just understand the meaning of this. Like you guys, I'm not sure whether you guys are thorough with your ratios and the rate of change, and definitely differential would not be of in your syllabus. So just try to guys read the definition once. I'm not telling mug up. Just write down in your notebook, just jot down. And once we are just coming into just solving the numericals, you'll automatically understand that the rate of change of my position with time is called speed. This is a definition. Okay, now coming to the second point, why it's Planck. Now definitely there's a formula for the speed. Now this is speed, that the unit you can already see over here, it's kilometer per hour. Now first of all, let me just type the unit. So how would you measure? So like in distance we did. So if you can just see distance, we measure in meters and kilometers. So similarly, speed we cannot measure in meter, right? So what will be the unit for speed? Unit for speed will be meter per second. And now what does this meter per second mean? That how many meters are you traveling in 1 second? Okay, I'll just come to that. Okay, guys. Or that's meter per second, and or you can say or there's one more unit, widely used unit, that's your kilometer per hour. If you can just read in your tachometer, it's your kilometer per hour. And definitely that's also scalar quantity, and I know it's getting a lot confusion for you guys, but now let's just come into the formula for speed. Okay, now what is the formula for speed? So speed is, as you can see, rate of change of position or magnitude of change of position. So change of position means distance. So this is only the change of position. If you guys can see the 1 kilometers, this is the change in position. So speed formula would be distance upon, that means distance divided by time. Okay, now distance divided by time. So that if someone asks you if someone asks you what defines speed, what is speed? Okay, now at that point of time you can just tell that this definition, that it's the magnitude of the rate of change of its position with time. In simple words, if I just say, you can just in simple words, if you just want to say through this formula, you can just tell the amount of distance covered in 1 meter, in 1 hour or in 1 second would be the speed. Okay, and you can also say that speed is your ratio of distance to the time. So the ratio words also you can just write down the formula, write down the definition, and as of now just write these 4 points, guys. Okay, definition I'm getting, I know it's getting a little bit confusing for you guys, but we will definitely solve it out. And if you guys have any specific confusion or a specific doubt regarding these or any topics what we are discussing till now, you can just comment down below. Okay, now we'll just see one more topic, and this half away I'll just take you guys through half away, and I'll tell you the reason for why half of way I'll just take you with displacement. In the next class starting itself, we'll just discuss, or someone from my team, my colleague, will discuss the difference between distance and displacement. And at that moment of time, I want you guys to do a little bit of hard work and just try to understand the theory of this, that what is the ratio of change of distance to time, and why is speed called as distance upon time, and these all things. Just try to revise these all things, and in the next class we can just have a better understanding. Even guys, you would be getting the maximum benefit of out of our videos, out of our courses, if you just try to understand it religiously. Okay, now coming to the topic of displacement. Okay, this is the last topic for today, and definitely, as I told, that I'm just gonna tell you half the way of displacement. And after this, I just want you guys to after the video ends, I just want you guys to just go through the notes whatever you have prepared, and the link below you will just get the PDF of this lecture, the PDF of this video. Just go through it. If any points you have missed, just see through it. Okay, now coming for displacement, I'm sure you guys would be knowing about go-karting, and even if you don't know about go-karting also, you can see that racing track over here. Okay, in this what happens, for example, this is the start point. Okay, this is a start point. Let me just write for you, start point. Okay, this is a start point, and a racer has to just take his or her car, and he or she has to go this way, all the way from here, all the way from back, and just reach back to this point. Now I just started from this point, I just started from A, I went till B. Okay, I went till B, then I went till C, and then back I just went to A. Okay, I'll just mark with the arrows also for you guys to better understanding. From A to B I went, I started from A, so my initial position is A. My initial position is A. I started from A, I went till B, then from B I just went from B to C, and then from C again I'm going back to A, as you can just see in this example. Now if I just ask you guys that how much, and let's suppose from A to B it's 1 kilometer, 1 kilometer, from B to C it's 2 kilometers. Okay, now definitely that will be under root of this, so wait, I'll just okay, from A to B, let's suppose for the better calculation, just let's suppose it's 3 kilometers. Okay guys, from A to B it's 3 kilometers, and then from B to C it's your 4 kilometers, and from C to A it's your 5 kilometers, as you can just see from Pythagoras theorem as well. Okay, now if I just ask you guys that let's suppose your A is your home. Okay, just for better understanding of you guys, let's suppose A is your home, B B B is your school, and what is C? Let's suppose for example C is a restaurant, or C is an hotel where you just went for having lunch. Now you just went in a day to three places. Okay, you started from your home, you went to school, took the lesson, from there you went to the hotel, and from hotel or restaurant you just went back to your home. Now if you can just see in this example guys, that your A was nothing but your home, right? Now if at this point of time when you are in your school, I just ask you how far are you from your home. Now just see the words. Okay, don't get fumbled with the confused or something, just listen to my words. Okay, you are standing in your school, and I just ask you how far is your home. Now from here if I ask you how far is your home, definitely you would say my home is 3 kilometers far. I can just go back from B to A, I can just go back from my school to home, and the distance would be 3 kilometers. Okay, very good. Now ask you the how far is your hotel, then you would say it's 4 kilometers from here, I have to go, I'm going now, I'm just going to the restaurant. And at this point if you're standing, if I ask you how far is your home, you would say that my home is 5 kilometers far guys. Now there is a possibility that you can while from hotel you can just go back to school and then go to home. At that point of time how much distance you would be covering? 4 kilometers in this way and 3 kilometers in this way. So at that point of time you can just tell my home is 7 kilometers far because I'm going via school. But if I'm asking you minimum distance from your hotel to your home, that's your 5 kilometers, because these three roads are available to you guys. Now again I'll just tell you for you guys. Okay, and just just try to think with me. Okay, you are standing at your school and you came from your home, you just went to school, you are in school, and now I just ask you that how far is your home. You're standing at B, so you will tell my home is 3 kilometers far. Now you just from your school you just went to the hotel, and I just ask you how far is your home from C, like from this point how far is your home. So there's a possibility you can just go this way, it will be short for you, right? This will be 5 kilometers. So this will be short to you, this will be 5 kilometers. You can just say my home is 5 kilometers from here, from C. Or you can even take one more route, you can go via your school. So 4 kilometers you can just go to your school, and then again 3 kilometers to your home. So this total will be 7 kilometers, this will be 5 kilometers. Okay, so now I think it would be clear for you guys. So now just see what is distance and what is displacement. So this whatever you can just see, 3 kilometers, 4 kilometers, 5 kilometers, these all are the distances. So these are the distance. Now you will say what is displacement. So let's just come to the definition first of all. If you can just read with me that displacement is rate of change of position with time, magnitude of change of position with time. Now you would say it's somewhat similar to the distance. If I can say, even distance was a scalar quantity. Let me just tell you the unit for displacement. The unit for displacement is also meters. SI unit I am talking about, meters. That's represented as m. Sometimes we also talk in kilometers. Now you would say, yaar, ye to yaar, somewhat it's coming same as distance, displacement. What the hell is he talking, right? This doubt is very common for you guys. Okay, now let me just tell you that displacement, this definition you will be getting in next class, so don't worry, this is just half you're seeing. Okay, displacement is the shortest distance. Just see the words, shortest distance, not displacement is your shortest distance between, this is a symbol for between 2 points. Okay, now just think on it. Okay, once this video ends, guys, just think on it that what is he telling, that it's the shortest distance between 2 points. So if this was my point A, wait, I'll just change the color. Okay, if this was my point A, okay, this was my point A, this is point A, and this point is my point B. So now there is a possibility I can go like this and just come. If these barriers would not be there, I can even just come down straight from A to B. Now the shortest distance to B is definitely this path, but due to there's no road possible, there's only one path, so I'm traveling more distance. So this is not my shortest distance. So this is not the displacement what I'm covering, right? Okay. Now even if you come through any way, you just from here you just go to whole world and just come to B. Still, if I just ask you what is your displacement from A to B, you will be telling that this is only my displacement. The shortest path is only the displacement what I have covered. This is my displacement. Now guys, I know it's a little bit confusing for you guys, so just see the next video. It would be coming down somewhere, or you can just check our playlist also. The second video of motion topic, we are covering this in detail, that what is the difference between distance and displacement. Some of the numericals also we are seeing, some of the numericals on this topic, that what is the distance and what is the displacement calculations. So some of your NCERT examples also we are seeing. Okay, so that's it for this guys, this class guys, and for the next class these all topics are we have decided to cover for you guys. So first you will be seeing what is velocity. First of all, displacement we will be seeing in detail and some numericals on that. After that we will be seeing velocity, we will be seeing acceleration, what is acceleration, what are the equations of motion, Newton's. Obviously you would be knowing this fellow. He's a very famous guy actually, and because of him we are sitting here and studying physics. So we would be studying equations of motion and a little bit numericals on that. After that you can just say that your motion topic is over. And yeah, that's it for this guys, this class guys. Thank you so much for joining, and my name was Yatat, and I hope to see you in the next video. Bye bye guys.